Hello, everyone. So today we're going to be going over Recitation 8. I'm sorry that I wasn't able to hold a recitation today, but I'll be flying out to California. So thank you for watching this video. So today we're going to be going over some externalities and the labor market. And we're going to go over a longer problem on efficient supply and cap and trade. So let's start with our first example, fishing in a purple pond. In Purple Pond, there are fish. So long as fishers do not catch more than 20 pounds of fish a day, the pond will remain stocked with fish. While the pond is open to the public, suppose the past few fishing seasons there are only two fishers, Ben and Jerry. Jerry's marginal cost of fishing is given by 2FJ, where FJ is the amount of fish he catches in pounds each day. Ben's marginal cost of fishing is given by 4FB. In previous fishing seasons, the price of fish was low enough that the pond was never, quote unquote, overfished. But this season, the price of fish jumped to around $30 per pound, which would mean that more people want to catch fish to sell them at a higher price. What can you say about the price of fish in previous seasons? It must have been below what? So we know for a fact that the marginal cost of Jerry of fishing is going to be given by 2F, where F is going to be the amount of fish that Jerry catches. Ben's marginal cost is going to be 4F, so with that same logic, FB is going to be the amount of fish in pounds that Ben catches. So what we can say is it must have been below. Let's try to work this out. So if the pond wasn't overfished, then that means that Ben and Jerry were catching less than 20 fish. So as long as fishers do not catch more than 20 pounds of fish, the pond will remain stocked with fish. So we know for a fact that FJ plus FB had to be less than or equal to the 20 pounds of fish, where if we were to go above 20 pounds of fish, then it would be overfishing. But in this case, we're not overfishing, so we know that our combined fish is going to be less than or equal to 20. So we also know that Ben and Jerry, they're going to keep catching fish up to the point where price is equal to marginal cost. And why do we know that? Because of the rational rule, where we keep doing something, in this case, catching fish, until the price at which we can sell the fish is equal to our marginal cost. So we're going to set P, which is the price that they can sell the fish, equal to 2FJ. And we're also going to set that equal to 4FB. And so all we're doing is we're setting P equal to the marginal cost of Jerry, and then equal to the marginal cost of Ben. So we don't have a price yet. That's what we're trying to solve. But we can solve this side of the equation. Let's try to solve for one variable. So if 2FJ is equal to 4FB, if we divide both sides by 2, FJ is going to be equal to 2 times FB. Or in other words, Jerry catches twice as many fish as Ben. Now, with that said, FJ plus FB must be equal to 3FB. How do we know that? Because FJ, as we solve for here, is equal to 2FB. So we end up with this equation becoming this equation, where 3FB is going to be less than or equal to 20, but in this case, we're trying to solve for FB. So we're just going to set it equal to less than or equal to 20. Then we solve for FB. So FB is going to be less than or equal to 20 over 3. So at most, Ben caught 20 over 3 pounds of fish. And then that means that at most, P equal to 4 times the amount of fish that Ben caught, 4 times 20 over 3, it's going to be approximately 26.67. And this number is going to be the price that motivated Ben to catch 20 pounds of fish. So that means that the price of the fish must have been less than or equal to $26.67. So let's just go over quickly how we did that, a quick summary. So first, we know that because Ben and Jerry are not overfishing, their total fishing supply is going to be less than or equal to 20. We know that Ben and Jerry are going to keep fishing until the price that they can sell the fish for is equal to the marginal cost. We repeated that step here. We'll reset our price equal to the marginal cost of Jerry, equal to the marginal cost of Ben. After that, we solved the new equality that we have here by setting 2FJ equal to 4FB. We divide by 2, and we found that Jerry catches twice as many fish as Ben. Now that we have that, we can substitute 2FB for FJ, and that'll give us 3FB. So now that we have 3FB, we can satisfy this condition by writing this condition. 3FB is less than or equal to 20. We solve for FB, and we find that the amount of fish that Ben catches has to be less than or equal to 20 over 30 pounds of fish. So now that we have this number, we figure out what price would motivate Ben to catch 20 pounds of fish. Well, that's simple. All we do is we get the marginal cost of Ben, which is 4FB, set it equal to our price, and we substitute our pounds, and that gives us a price of $26.67. And that's going to answer, what can you say about the price of fish in previous seasons where the pond was always stocked with fish because there's no overfishing? Well, we know that the price must have been below $26.67. And there's your answer. Now, this season, when the price is $30 per pound, how many pounds of fish are caught each day, at least in the beginning of the season? So, since both fishers catch fish such that price is equal to marginal cost, we're going to end up getting, in this case, we know the price, 30 is equal to our respective marginal costs, which are 2FJ equal to 4FB. So here we don't have to use this condition as we did before. Instead, we could just do it individually. So 30 is equal to 2FJ That'd be 15 is equal to Fj, such that Jerry catches 15 fish, or 15 pounds of fish. Now we do the same thing for Ben. In this case, it's going to be 4FB is equal to 30. Divide by 4 on both sides. FB is going to end up being 7.5 pounds of fish. This is going to be what Ben catches. So Jerry catches 15 pounds of fish, and Ben catches 7.5 pounds of fish. And that's going to be our answer. Now, Professor Burke specifically mentions, however, at least in the beginning of the season. Now, the reason that we do that is if we consider how many pounds of fish Jerry and Ben catch at the beginning of the season, that ends up being 22.5 pounds of fish. However, we know that whenever the pond is overfished, it's because we went above 20 pounds of fish caught by Ben and Jerry. So eventually, although this is the rate that we would go at a price of $30, we only end up getting 20 pounds of fish before the pond is overfished. So eventually we're just going to run out of fish. And the way that we can do that is we make a fish with dead eyes because all the fish are being fished. So they're not going to be able to keep this rate up. The next part of the question asks, what will happen to the population of fish? What is this situation called? Now, the population of fish when price is equal to $30 per pound of fish. So sadly, as we sort of explained, the fish population will not sustain itself. Eventually, Ben and Jerry are going to keep fishing until there are no more fish. And this is a perfect example of the tragedy of the commons problem. So fishing in the purple pond is not excludable because it's available to everybody, but it is rivalrous, which means that Ben and Jerry are going to compete for the fish that they fish for. So with these two conditions, we find that the fish pond, or purple pond, is the tragedy of the commons problem, which means that people are going to keep using up those resources until there's none available for anybody. So with that in mind, is this a negative externality? And explain what is the external cost in words. So because the pond is not going to have any fish left, it is undoubtedly going to be a negative externality. So the fishers in this case, they only consider their private costs, as we did when we set price is equal to marginal cost, and they don't consider the cost of depleting the pond of fish. So, for example, if Ben and Jerry were the only two people that fish there, then they probably would take that cost into account, but the problem states the pond is open to the public. And we know that because it's a non-excludable good. So Ben and Jerry are only going to care about price is equal to marginal cost until there are no more fish in the pond. So it's going to be a negative externality because they're not being fished anymore can have negative effects on the rest of society. For example, one effect could be a boy who really loves fish who can no longer see fish. And now that boy is really sad. Another example could be, let's say that there are animals in the ecosystem, for example, a bear that relies on the pond to eat fish. That could cause a negative externality on the environment, which can lead to even more negative externalities for people who enjoy the environment and so on. So overall, fishing until there are no more fish in the pond is not a good thing, and you should not do that. Now, assume that the government wants to put a cap or a quota on fish, or on pounds of fish being fished. What is the efficient level for the cap? So the efficient level is just going to be the level of fish that are caught that maximizes the surplus of fishers and anybody else while also not depleting the pond entirely. So we were told that in order for there to be no overfishing, my bad, we have to stay at 20 pounds. So naturally, the quota that we would set is just 20 pounds. The efficient quantity is 20 pounds of fish a day. That way, people can keep fishing there because there are still going to be fish for there to be caught. Now, suppose the government decides to directly sell permits to Ben and Jerry. We did this last recitation. At what price should it sell the permits to ensure the efficient quantity? So the efficient quantity is going to be, we're going to call that quantity efficient, and we know that that's going to be 20. Now, earlier in the video, in question 1, we figured out that for Ben and Jerry to catch 20 fish, the price that motivates them to catch 20 fish is $26.67, where Ben would end up catching 20 over 3 pounds of fish, and Jerry ends up catching 40 over 3 pounds of fish. So now the price that's being set, and we'll call that P competitive, is $30. So compared to the price of $26.67, P competitive is going to be way too high. So the government should set a price of the permit that is equal to the difference between the competitive quantity, or the competitive price, pardon, and the efficient price. So the price of the permit, let's call that PP, kind of funny, PP is going to be $30 minus $26.67 for a total, pardon, of $3.33. So let's try to clarify what this number means. So originally, to catch 20 fish, you need a price of $26.67. In other words, fishermen, Ben and Jerry, are going to be selling the fish that they catch at a price of $26.67. Right now, the market is offering them $30, so they have an incentive to jack up the quantity that they catch of fish. Makes sense, because if you can sell it at a higher price, you're going to want to have more things to sell. So what this permit does, the role of the permit is add an additional cost to essentially offset this $30. So that's why we end up with $30. You bring it down by $3.33 to get us to the price that Ben and Jerry would sell their fish, where we come up with the efficient quantity of QE is equal to 20. So again, the $3.33 permit is just going to be a way to jack up the price to make it more expensive to catch fish. So the fishermen, Ben and Jerry, they end up wanting to go back to a level of 20 fish. Okay, so now number 7 asks, compared to just giving the permits away, how does this affect total economic surplus? So there are two scenarios. A scenario where Ben and Jerry can bargain, and then a scenario where they can't bargain. So as we learned in recitation, bargaining is going to lead us to the efficient outcome, which is QE and then PE. So what happens here is that the government is giving away 10 1-pound permits. So let's say the government gives away 10 1-pound permits to Ben and then 10 to Jerry. So in total, it's going to be 20 1-pound permits. So, as we've established before, it's more efficient for Jerry to catch more fish than Ben because he has lower costs. So, the marginal cost of Barry, not of Barry, my bad. The marginal cost of Jerry is going to be 2FJ. Meanwhile, the marginal cost of Ben is going to be 4FB. So, as we can see, just simple algebra, 4 is bigger than 2, so Jerry has lower costs. So, because he has lower costs, the right to catch an 11-pound fish is going to be more valuable to Jerry than the right to catch a 10th pound of fish to Ben. So, what I mean by that is that whenever we're trying to figure out cap and trade, in this case, will they trade the permits to each other? You want to compare the profit that Jerry makes versus the profit that Ben makes. So the profit that Jerry makes is going to be price minus the marginal cost times quantity. For Ben, it's going to be the same thing. If Ben has a higher marginal cost than Jerry, that means that for each unit, Ben is going to make lower profit than Jerry. So if right now Jerry has 10 permits, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then Ben has 10 permits, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Jerry is going to value catching an 11-pound of fish more than Ben is going to value catching his 10th pound of fish. So this process, basically what's going to happen is that Ben says, okay, well, you're right, Jerry. Your 11th pound of fish is going to, it's going to make you happier than this 10th pound of fish is going to make me. And then we keep repeating this process where it may be the case where Jerry's 12th pound of fish is more valuable to him than Ben's 9th pound of fish. And this one keeps getting traded over as well, or is traded over as well. And this process where we just compare the 10th, for example, in this first one, the Q is going to be 10, and then Q is going to be 11, Q is going to be 9, Q is going to be 12. We keep comparing this, and whoever has the higher profit for each quantity should be the person that gets that permit. So this process is just going to keep repeating itself and repeating itself until Jerry has enough permits to catch 40 over 3 pounds of fish, and Ben trades its permits away to where he only catches 20/3 pounds of fish. And this is going to be the efficient outcome of 20 pounds of fish. So this is with bargaining. Now, if we're in a scenario where we can't bargain, first, let's talk about our efficient quantity. There would still be 20 pounds of fish, so we're going to check that off as yes, we have the efficient quantity. However, the fish, in order for them to be caught in a socially efficient way, we want them to be caught in a way that the total surplus for society is increased. So in this case, Jerry's increase in total surplus is what's important. But under no bargaining, Jerry's surplus can't increase. So they're going to be caught. We're going to be in a situation where both Jerry and Ben have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, where each one of them has 10 permits. But first, Ben's marginal cost is going to be greater. So he's actually going to be spending more on however many units that should be going to Jerry, he ends up catching. And Jerry, he's going to lose out on profit, or in this case, let's just call it profit so we're not confused. So Jerry's going to miss out on profit, and Ben is going to incur unnecessary costs. So because of that, when Ben and Jerry can't bargain, yes, there's going to be the efficient quantity. However, they're not being caught in the most socially efficient way. So total economic surplus actually ends up going down. Whereas in this case, total economic surplus stays the same. Okay, so the last question in this example is, does the government selling permits versus the government giving away permits have any impact on producer surplus? So this one's fairly simple. So we know that the producers are going to be Ben and Jerry. So Ben and Jerry are going to be the producers. The logic is pretty simple. So first, in a scenario where the government is selling permits, the producer surplus, or the profit that you make, is going to be what you make, P, minus the marginal cost that you incur with the permits, times Q. That's going to be your profit. If the government just gave it away, or let's just call this free fishing, where they just give the permits away, the profit that Ben and Jerry are going to make is going to be P minus C without permit times Q. And so what I mean by without permit is, let's actually rename this free permit. So we're going to compare the marginal cost with the permit with the marginal cost where the government just gives away permits. And if they sell permits to you, the marginal cost that you incur by buying a permit is clearly going to be bigger than the marginal cost that you incur when the permits are just being given away. So if our producer surplus is related to our profit, if we look at something like a graph, we have our supply curve and then our demand curve. We know that our producer surplus is going to be from the price that we receive down to our supply curve. But if the price that we receive ends up being lower, we can directly correlate that to a decrease in the producer surplus, where now our producer surplus is just this green triangle. Okay, so now we're going to go over some quick substitutes and complements questions. So first, let's talk about the relationship between capital and labor. The number of bank tellers declined from an average of 20 per branch in 1988 to 13 in 2004 as ATMs replaced human tellers. Sorry about that. Does that suggest that capital and bank tellers were substitutes or complements? So, substitutes means that you can replace one with the other. Complements means that they go together, like peanut butter and jelly. In this case, if ATMs are replacing human tellers, then capital and bank tellers are going to be substitutes. So, in this case, substitutes. The ATMs displace the tellers. However, the increase in the use of ATMs and the decrease in the amount of labor meant that the cost of running each branch fell. So increase in the use of ATMs meant that the cost fell. Banks responded by increasing the number of urban bank branches by 43% in the same period. Note that increase in the number of branches is greater than the decrease in the number of workers in each branch. So, on the whole, there was an increase in the total number of bank employees. So ATMs shifted employees' work from routine tasks like deposits and withdrawals towards skilled machines could not provide, such as sales and customer service. So what this is saying is that, yes, ATMs displace tellers, but increased productivity caused there to be more banks, and in turn, more employees. So if ATMs are capital and they lead to more banks and in turn more employees, where employees are labor, then in this case, we find that capital and labor actually end up being complements, where the ATMs ultimately increase banks' demand for labor. Now, a more complicated example has to do with the income and substitution effects of a wage increase. So suppose that leisure is a normal good. And what a normal good means is that as income goes up, you're going to want to consume more leisure. So the question is, true, false, or uncertain? As a person's wage increases, she will consume more leisure. So let's think about this from the perspective of the person whose wage is increasing. So if I get richer, let's say my wage goes up. From $15 an hour to $100 an hour. I had a super big pay raise. I got the promotion to end all promotions. So if I'm being paid hourly $100 instead of $15, well, one thing that happens is I can afford to work less. And if I can afford to work less, that means that I'm going to consume more leisure. In other words, I'm going to slack off more if I can afford to work less, because I'm going to make the same amount of money in 1 hour that I would make in 5 hours before, then I can afford to work less. However, if the trade-off is between leisure and wage or extra money that you make, the trade-off between leisure and wages is just going to be money. So the opportunity cost of leisure actually ends up being the money that I could have made by working more hours. So now I'm conflicted because if I'm being paid more, then I can afford to work less and I can consume more leisure. However, if I'm making a boatload more money, then the opportunity cost of leisure is going to go up a boatload as well. In other words, slacking off is going to be a lot more expensive because now instead of foregoing $15 an hour, I'll be foregoing $100 an hour. So, as we can see, there are two conflicting events. The first one, where we want to consume more leisure, we're going to call that the income effect, where because we now have a higher income, we can afford to work less, and therefore we can consume more leisure. If you think about Jeff Bezos, for example, who is a billionaire, he's going to have a lot more free time if he chooses to have that free time than a low-income worker who has to work to survive. So that's the income effect. Now, whenever we have the opportunity cost of leisure being so much more expensive, we're going to want to consume less leisure so we can go to work and make all that money that we are going to make if we don't slack off. In other words, we're going to substitute leisure with more hours of work to make more money. And we're going to call this the substitution effect. So these effects contradict each other. The income effect is saying consume more leisure, and the substitution effect is saying consume less leisure. So the correct answer would be uncertain. As a person's wage increases, she may consume more leisure, but she may also consume less leisure. It just depends on whether the income effect or the substitution effect is stronger. Now, I'm going to end this example off with a graph that you'll learn in intermediate micro if you choose to take it, where if we have a graph of wage on labor, where less labor means more leisure, then what ends up looking like is like this. So the substitution effect is saying as our wage increases, we're going to want to work more hours. But when our wage increases past a certain point where you become Jeff Bezos, where every increase in wage becomes very marginal, the income effect starts to tell you to work less. So this effect here is going to be the income effect, and this effect here is going to be the substitution effect. Where, and then just to clarify some things here, this is going to be hours worked, and then this is going to be the rate in dollars. Now, we're going to finish up this example with a minimum wage question. Consider the very competitive market for labor at fast food restaurants in a large city where all fast food jobs are essentially the same, so that workers have no preference working at one place or another. Suppose the minimum wage is $10 an hour, but then the city government imposes a minimum wage of $12 an hour. According to the model from class, are the following statements true, false, or uncertain? Explain. So, because of the minimum wage, let's go over A first. So, we start off in a market for labor where we have wage on the y-axis and hours worked on the x-axis. The supply of labor looks like this. And in this case, the supply of labor are going to be the employees. And then we have the demand for labor looking like this, where in this case, the demanders are going to be the employers. So we're at an equilibrium price of 10. And at that equilibrium price of 10, we're going to be supplying some L star. But then the government steps in and imposes a minimum wage. In this case, the minimum wage is going to be exactly the same as a price floor, where the government says you need to charge or you need to pay your employees at least this much. So the government steps in and sets a price floor or a minimum wage of 12. At that minimum wage of 12, employers are only going to demand LD, number of hours worked, and suppliers, because they're at a higher wage rate, in this case employees, they're going to want to supply more work. We're going to call that LS. So now that we have this graph fresh in our minds, let's answer some of these questions. So first, the total number of hours worked in fast food restaurants falls. So in this case, that is going to be true. Why? Because as we've covered with price floors and price ceilings, the left side of the market is going to decide how many hours of labor are going to be supplied and demanded. So in this case, LD is less than L star. So the total number of hours worked in fast food restaurants falls. We'll say that's true. Now, B says all people who worked at fast food restaurants before the minimum wage change will be better off. So, assuming that these people are not being fired, they're going to receive a higher wage. Because they're receiving a higher wage, they will be better off. So this is going to be true. Now, C is saying the economic surplus of fast food restaurants would increase. So this is saying that the economic surplus of employers is going to increase. Well, let's see if that's true. So originally, the economic surplus of employers is going to be the consumer surplus, which goes from our demand curve down to our price. That's going to end up being this green triangle. However, then our price goes up to 12. Employers have to pay their employees more. So it goes from our demand curve down to our new price. And it becomes this red triangle instead. And because of that, we know that letter C is going to be false because the economic surplus of fast food restaurants or employers would actually decrease. Now it's saying the economic surplus of fast food workers, in this case the employees, as a whole would increase. So let's figure this out now. So first, we know that we're going to be looking at the economic surplus of employees. So we want to look at our producer surplus. Originally, our producer surplus went from the price that employees are being paid down to the marginal cost curve. And it's going to be this green rectangle. But now it's going to go from the price that we're being paid, 12, down to the hours that we're providing in this case. And it's going to end up making this trapezoid here. So first, our producer surplus was this triangle. But now our producer surplus is this trapezoid here. So in this case, it's actually uncertain as to whether the economic surplus of fast food employees, or workers as a whole would increase, because under the scheme, under P is equal to 12, we lose out on all of this, but we gain this rectangle. Now, with the price being equal to 10, we gain this triangle, but we don't have this rectangle. So it ultimately just ends up being, is the trapezoid or is the triangle bigger in area? But because we don't have information for L star and LD, we don't know. And so in this case, this is going to be uncertain. Awesome. And that's pretty much going to be it for this recitation. If you have any questions whatsoever, feel free to reach out to me at ada82@georgetown, blah, 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 blah. Okay, have a great day. Goodbye.